This is review problem number 2 for assessment number 4. It says find the total area of the region between the x-axis and the graph. So we've done a problem like this before, and what it means is they want you to find the area between the x-axis and the graph, no matter if that's positive or negative. So they really want the absolute value for the area, because remember, if the region's below the x-axis, they consider that to be a negative area. If it's above, it's a positive area. So when you normally integrate, you would combine those together, add those, and the negative area cancels out some of the positive area. Well, they want to know the total area, so they really want the absolute value of that negative area combined with the positive area. Now, the first step to solve this problem is we want to find our roots. So let's go ahead and find those roots first. So the roots of y equals x cubed minus 3x squared plus 2x. So to find the roots, we say 0 for y equals x cubed minus 3x squared plus 2x. We do some factoring here, and we get 0 equals, we'll factor an x out, and that's left with x squared minus 3x plus 2. We'll factor some more. 0 equals x. If I factor this into two binomials, it'll look like so. And 2 only has two factors, 1 and 2, and if I want it to be negative 3, that means they both have to be negative. So negative 1, negative 2. And we know that when we multiply the negative 1 and negative 2, we get the 2, negative 1x, negative 2x gives you the negative 3x, so we're good there. So now we can say, okay, x equals 0. This means if we use the zero product property, x equals 0, or x minus 1 equals 0, or x minus 2 equals 0. So then that means x equals 0, or add the 1 over, x equal 1, or x equal 2. So that means we have 3 roots here. Remember, we're trying to integrate this from 0 to 2. So I want you to see what happened here is we're integrating from 0 to 2, and one of our roots are technically the endpoints here. So that's going to come up when we actually go to evaluate this, derivative, or not derivative, antiderivative. So let's go ahead and look. I want to see what the graph looks like so I can picture the region. I think the easiest way to see what the graph looks like so that we can picture the region is to, we know the roots, but we don't know where is the slopes positive and negative, so we can't really picture the function right now. So I think what we should do is take the derivative of this and then use our roots to figure out where the slopes are positive and negative. So let's go ahead and do that. Let's take the derivative of this, and that would be y prime equals 3x squared minus 6x plus 2. Now, I'm not overly concerned with we're just going to skip this part. We're just going to skip this part because this part doesn't really even matter. What matters is we know the roots, and we're going to integrate this region. And because we're going to do the absolute value anyways, it doesn't matter what the function per se looks like. We know it's a cubic function, so it's going to have some wave to it. So this part doesn't matter, so we're going to skip that. Let's go ahead and just go into the integration then. Well, we're going to integrate from 0 to our root. So we're going to integrate from basically root to root because we've got all 3 roots inside this region. So we're going to integrate from 0 to 1 to find that area of this x cubed minus 3x squared plus 2x dx. And we're going to add that with the integral from 1 to 2 of the same function, of course. And we want to make sure that these are absolute values of each of these integrals, because we want the total area, and what that means is we want to make sure that we're getting the absolute value not a negative area. We want both of them to be positive so we get the total area, both top and bottom. So let's go ahead and take the integral here. And when we do that, we're going to get integral, well, we're going to get x to the fourth over 4. Let's go ahead and do that antiderivative. So that'd be x to the fourth over 4. The antiderivative of this is minus 3x cubed, right? Raise the power by adding 1 and then divide by that power over 3 plus 2x squared over 2. And this is the antiderivative, so let's go ahead and say that this is going to be from 0 to 1, and this is still the absolute value, plus, and we can write the exact same thing over here, absolute value of x to the fourth over 4 minus 3x cubed over 3 plus 2x squared over 2 from 0 to 1. Okay, so let's simplify this a little bit. That'll be x to the fourth over 4 minus x cubed plus x squared evaluated from 0 to 1, and make sure we take the absolute value. Plus, do the same thing here, x to the fourth over 4 minus x cubed plus x squared. This one's evaluated from, I hope I screwed this up. This should have been 1 to 2. So this would be from 1 to 2. Absolute value. All right, so let's actually plug these in then. Well, if I plug in 1, I'm going to get the absolute value of, and I prefer to plug these in the calculator. So let's go ahead and do that. I'm going to use my calculator to kind of plug these in and get these right. So I take the top one, plug it in, and I subtract out whatever the bottom one is plugged in and take the absolute value. So let's store 1 as x. Let's put in this function, so x, and actually I can use fraction mode here, so we're going to do that. I'm going to delete this and we're going to use a fraction, and we can say x to the fourth over 4 minus x to the third plus x cubed, no, x squared. Hit enter, we get 1/4. So that means we're getting 1/4 here, minus, when I plug in 0, you can see that all the x values will just cancel, so I get minus 0. That'll be plus the absolute value of, let's plug in 2. Well, when we plug in 2, so store 2 as x, so 2 stored as x, and grab that function, we're going to get 0. And that's because 2 is a root, right? So obviously at that root, the slope is, at that particular spot, because it's a root, it's going to give you a value of 0. So we're going to end up with a 0 here. And then we're going to plug in 1. Well, we already know what 1 is, which is 1/4. So we can say minus 1/4. And then we can actually combine those. So that's going to be 1/4 minus 0, which is 1/4. When you take the absolute value of it. Plus 0 minus 1/4 is negative 1/4, but you take the absolute value, that's 1/4. And so our areas of our two spots in our graph are 1/4 and 1/4. You add those together, that's 1/2 for your total area. And that's for you, problem number 2.